welcome back to your YouTube channel. In today's video, we will be diving deep into the fascinating world of trigonometric functions. Especially, we will be exploring how to graph the trigonometric function effectively. Whether you are a student studying the trigonometry or just someone curious about the beauty of mathematical curves, this video is for you. Don't forget to hit that subscribe button and ring the notification bell so you won't miss any of my videos. So let's get started. Before we jump into graphing, let's quickly review the basic trigonometric function, which are sine, cosine, and tangent. We will discuss their definition and how they relate to the unit circle. If you need more information on this concept, you can refer to my previous video, Trigonometry for Beginners. Understanding these fundamentals will be crucial as we move on to graphing. If you're already familiar, so you can feel free to skip ahead to the next section. Before talking about any other concepts, I want to talk to you about an angle. So as you know, the angle is consisted of two arms or two hands, right? Two hands or two arms, okay, which are connected at this connection point, and this is the angle, okay? This is the angle from here to here. So usually the two arms have got a name, initial, terminal, okay? Initial, terminal. So any of these arms can move and it can increase, right? Increase the angle between. So the angle is defined by this distance between the two hands, okay? So here, the same angle we talked about, I want to introduce you to a terminology that is most commonly used, especially in trigonometry when we are dealing with angles. When the initial arm, this is the initial arm, when the initial arm of the angle is on the positive x-axis, and the terminal arm could be anywhere. So this is the terminal arm, this is the other arm which can move anywhere, right? So this terminal arm could be anywhere. It doesn't matter. It could be on any of the quadrants. This is called the angle is in the standard position. So when the initial arm is in the positive x-axis and the other arm is moving around in any of the quadrants, we call it the standard position of an angle. Remember, so this one is constant, this one is moving, okay? And one more definition you have to learn. Each circle is divided into 4 equal parts or 4 quadrants. And this is how all the mathematicians number them. If you move anti-clockwise, quadrant 1, 2, 3, 4. So whenever we refer to quadrant 3, this is the one. Okay, you have to learn how they are arranged. I just mentioned, we'll start with a definition. If you remember, we have 3 basic trigonometric functions: sine, cosine, and tangent. Try to remember, like sine, it's the opposite side over the hypotenuse. And remember, guys, whenever we're talking about trigonometry or the trigonometric function, we always refer to an angle. So this is your angle, theta. And when we talk about the sine of theta, that means the opposite side over hypotenuse. So that would be, if I use the acronym, that would be SOH. Okay. The other one for cosine of angle theta, right? It is adjacent over hypotenuse. So, okay. And the tangent of this angle is the opposite over adjacent, which is TOA. So some people, if you watch other videos or, let's say for some textbook, they might refer to the SOHCAHTOA rule. SOHCAHTOA rule This is the acronyms of the three basic trigonometric functions. The other concept that I will quickly go over is this unit circle. If you need more information, you can refer to my previous video. So this is a unit circle. That means the radius is 1. For unit of measurement of angles, we have two very important units like degree and radian. These are not the only two, but these are the most common ones. So here I drew a circle, and this is a unit circle again. That means the radius is 1. Remember guys, if I start from here and go one revolution or one round the circle, that would be in degree 360 degrees. Okay, so this is one very famous and common like unit. So each round of a circle or each revolution, okay, starting from here all the way to here, that would be one turn, one revolution, and it would be 360. But some people, they prefer to use another unit of measurement, and that is radian. The same distance in radian would be 2 pi. So in other words, 360, it's equal to 2 pi. Remember guys, you have to be able to convert between these two units. So 360 degree, it's equal to 2 pi, or you can divide it consecutively by 2 and get all these ratios. Any of them works, but the most important thing is that you have to know how to convert between any of these two. And then we have positive and negative values. What I mean is positive, it's when you move in this direction, and negative means if you move in this direction. Like positive is anti-clockwise and negative is clockwise. Okay, and now time to dive into the main event, which is graphing sine and cosine functions, sine and cosine. And I'll guide you through the step-by-step processes, explain you how to determine the amplitude, period, phase shift, and vertical shift. We'll also cover how to identify the key points on the graph and create a smooth curve. So stick around for some pro tips on visualizing the graphs more effectively. Okay guys, remember we said the two most basic functions. We start with sine and cosine. Okay, remember the sine graph is in blue, and the red one, which is cosine, is shown here. As you can see on the x-axis, I have two units. The top one is in radian, the below one is degree. As you can see, both of these units can be used. There is no preference like in terms of using them. It just depends on the application. So the radian and the equivalent in degree. Radian, the equivalent in degree. So these are exactly the same point on the unit circle. Okay guys, so remember, when we want to do a graph in algebra, we are like, especially for this course, you're dealing with two variables. Here, your two variables are y and x, dependent and independent. So the independent variable here is x, and the dependent one is y. For any graphing, you give values to the independent variable, and then you find the values for the dependent value, right? Make a table, right? After that, find a point on the xy axis and then connect them together. So this is the general shape. Have it in mind. Then I'll walk you through on how to do these steps. So here, I'll start with the very basic ones, and then we will do some more complicated or more advanced examples. Remember guys, as I just mentioned, whenever you want to do a graph, let me move this away. Okay, whenever you want to do a graph, you should start your graph by finding some points. So let's say sine of x. So x is your angle. Remember, like the only difference with trigonometry function is that instead of using simple numbers like 0, 1, 2, 3, 4, we have to use the most common and simple to calculate angles, right? So again here, let's say 0, 30, 45, 60, 90, 180, 270, and last one is 360. Okay, here I'm using degree as my unit of measurement. It's only a matter of preference, but you know that at any point you can just convert between the two units. So here I'm using degree. That's why I'm going with 0, 30 degree. So this is a symbol you can use for degree, okay, to differentiate between the different units, okay? So now use your calculator, put it in degree mode, and then calculate with me the values. So sine of 0 in degree, it's 0. 30, it's 1 divided by 2. 45, it's 2, square root of 2 over 2. Here, square root of 3. Here, it's 1. And now, calculate sine of 180. Yes, you're correct. It's 0. Now, calculate 270. It is minus 1. And here again, it's 0. The reason why I picked so many points is that let's assume this is your first time you're being introduced to this graph and you're not very familiar with the general shape. So I picked one period of the function. These trigonometric functions are called periodic functions because they have units, okay? They have a building block in one period and then it keeps on repeating itself from negative infinity to positive infinity. So if you can find the shape in one period, okay, then you can keep on repeating it and get the whole shape from negative infinity to positive infinity. So now you have the shapes, you have the points. Okay, let's put it in the graph. So this is your x, this is your y. Remember, x, this is how I go 0, 30, 60. Okay, I have to elongate it. So 90, 120, 150, 180. Okay, so sine of 0, it's 0. Sine of 30, so if this is 1, this is negative 1. Sine of 30, it's halfway through. 60 is 0.7 almost. Then this one is 90. So sine of 90, let's see, this is 1. Sine of 90 is 1. Okay, now 120, 150, 180. So 180 is 0. Okay, then 210, 240, 270. Okay, so you can see I'm almost there. So this is it. Okay, and now this is plus 1. Okay, remember guys, here, okay, this is negative 1. Okay, now this is 210, 240 at 270, it's negative 1, right? And then 300, 330, 360. Okay, so I can connect this one to this and this one to this. All right, so this is like almost the shape. It's not a perfect one, but this is the shape. This is the general shape. This is one building block. But remember, guys, this thing repeats itself. Okay, from negative infinity to positive infinity. So this is in degree, and you can easily change it into radian. So let's say here in radian 0. Oh my god, I made this Just to let you know, I made a mistake here, so 0 should be here. I don't know why you put it here. Anyway, so if you want to convert each of these into radian, that would be pi divided by 6, pi divided by 3, pi divided by 2. So can you see, like, the shape is the same. No matter what unit you use, the shape is the same. So this is the shape I did with the computer. The blue one is the sine. You can see the perfect shape. It's up to scale. This is -1, +1, the two different units. For cosine, you actually do the exact same steps, and you will see that the shape of the sine and cosine is very similar. It's just the cosine, the values, the maximum, like it start the 0 would be at -90 degrees. So maximum, both of them have got the same maximum, the same minimum, and the period for both of them is the same thing. So here you can see that if you consider 0 the starting point, 2 pi, in 2 pi you would have one cycle for the sine. For the cosine, you can see that if you start from here, okay, which is -270, in 90 degree, okay, you would have one full period. And if you calculate, it's 270 here, 90 here, 360. So for both sine and cosine, in the most simple form, the period is 360 degrees. Now let's move on to the third main function that we have been discussing, and it is, what is it again? Yes, tangents. So I'll start doing the most simple form of tangent function. So y it's equal to tangent x. Again, what I have to do, remember guys, I have to here you have to be a bit more careful. So here you have sine and cosine. The cosine is in the denominator. In other words, the cosine can never be 0. What values make your cosine 0? Okay, let's refer to our graph. Okay, so your cosine it's 0 at 90 degrees and 270, right? At 90 and 270. So cosine 90 equals to cosine 270, right? It's equal to 0. These points are troublesome. We have to really watch out for them because at this point, the denominator would be 0. And when the denominator is 0, your fraction, it's not defined, right? When it's defined, when a function is not defined, you can't just plot it at this point. I'll show you what to do in that case. So let's start with finding the values. So 0, 30, 45, 60, and 90, 180, okay, 270, 360. And now let's calculate the values. 0. Okay, I already calculated the values for 10 of different angles. You can use, again, your calculator, put it in the degree mode because now I want to do the shape in degree mode and then find the values. So 10 of 0 is 0, 10 of 30 is square root of 3 divided by 3, 10 of 45, it's 1, and then 10 of 60, it's actually the sine of 60 over cosine of 60, which is square root of 3. So I just rounded up. So here again, what you have to do, you have your x and y, okay? So this is 0, 30, 60, 90, right? And as you can see on 90, sine of 90 is 1, but cosine of 90 is the value which is troublesome because it's 0. Then at 90 degree, that means your graph, your tangent, it's not defined, right? So remember, this is 90 degree. It's not defined. Another point which your graph is not defined, it's 270. So almost, let's say here it's 270. Again, at this point, your tangent, it's not defined. But let's see the values between 0 and 90. So at 0, it's 0. At 30, it would be 0.5 almost. At 45, which is around here, it's 1. Okay. And then at 60, it's here. Okay. But 90, right? 90 is a very important point. It's your asymptote. Like, that means your graph gets so close to this line, but actually never touches it. Okay. So here, this is the curve you would get. And now let's do the rest. So here at 90, I don't have it. So 270, remember this is it. 180, it's 0. Okay, so I need to see the values between 90 and 270. So to give you an idea, let's find the value of tangent 91 right after this asymptote. So the tangent of 91, let's say it's 1.6 something. So it is, let's say 1.63. Okay, let's start doing the values. So let's say you go and find the tangent of 91. I want to see the shape right after this asymptote. So it would be negative 1.6 something, right? And then you can give different values to get the shape, right? So in order to get the shape, you can find different values and then find a few points and you will see that your general shape would be something like this. Okay, so again, I did it with a computer and this is the shape you should expect. Okay, so 0, this is your point 0, 90, 270. And as you can see, at 90 and 270, it's not defined. So we have a vertical asymptote. And then this is the general shape. So if you look closely, you will see that, let's say from negative 90 to 90, you would have one of these perfect building blocks, which is here. In other words, you could say that your period is 180 because 90 here, 90 here, it's 180. And you can see in each period, it repeats itself, right? So how many times it's repeating itself? 6 times. So if I want to recap the period of a sine and cosine, okay, sine and cosine in its most simple form with amplitude 1, it's 360. That means in 360, I would have one full cycle, okay, one full shape. But in tangent, the period, it's half of it, right? Okay, let me use these two. So these two are smaller so you can see them in one go. Okay, the top one is tangent, the below one is sine and cosine. This is how you can compare the graph. Here, the most important thing to remember is that when you're doing here, like you should have an idea of the general shape and you should have an idea of the periods. And when you know these two, you know that if you find the shape in one period, you would know that it keeps on repeating itself from negative infinity to positive infinity. To give you another example, I did this one. So the blue one, it's sine x, which is the most simple one, but the other one, the red one, it's sine 2x. Excuse me, 2 times sine x. That means whatever value you get for sine, you have to multiply it by 2 and then plot the points, then connect them together. So as you can see here, the number in front of it, which is called the amplitude, has been doubled. That's why in the blue one, the amplitude was 1, but the red one, the amplitude is 2. So the number right in front of it, right in front of the trigonometry function, it's called the Amplitude. Perfect. So the amplitude could be any number. It could be positive, negative. It doesn't make any difference whether it's positive or negative. But the thing is, it just changes the maximum and minimum. For sine and cosine, the maximum and minimum, it's always between -1 and +1. But here, when you have an amplitude multiplied, so the new amplitude would be the number right in front. This picture, this is another picture, so you can see all three functions in one, actually in one go. Okay, all these three functions. Okay, I'm gonna stop this video here because it's getting too lengthy. I will create another video, but remember guys, this is only part 2. We will continue with part 3, which is talking about phase shift, domain, range, and all these different stuff. Before I finish this video, I want you to remember, when we're talking about the domain and range of a function, one of the easiest way to find these values is by graphing them. So let's assume here you already graphed your function. Okay, this is your sine, right? You already graphed it. When we want to find the domain, that means all the values of x which this function is actually defined for. And remember, as I just mentioned, the domain can be any, like from -infinity to +infinity. -infinity here, +infinity. And for this specific trigonometry function, the range, which is all the permissible values, right? All the values of y which is covered. So it would be from -1 to +1 for sine. For cosine, -1 to +1, right? But for tangent, it's a different story. So when you want to define the domain, you have to be careful here. All the real number except these specific dotted points, right? Because here your function is not defined. But how about your range? Here your range is actually all the real numbers, because these green graphs can go all the way toward +infinity, and from the bottom it can be continued to -infinity. I hope this second video helps you more, but stick around for the third part, which will be published soon. See you soon.